designed to minimize the distance travel. We also want to give them a storage system for the pallets to, well, they don't have one, so we wanted to give them one so that they could store and retrieve pallets efficiently. We wanted to standardize their workflows since they don't have any standard work procedures like I mentioned. And we also want to do a level load analysis to determine how many workers we needed to satisfy the current demand. Now Jessica is going to talk about the analysis.
So these are the 3 areas we decided to look into. We wanted to see the common sources of waste within the processes. We also wanted to compare the Puerto Rico and the Miami warehouse. And in addition to that, we wanted to figure out different layout ideas in order to improve the flow. So here's I guess a process breakdown of the 2 operations within the warehouse. Basically, there's a loading process which consists of a forklift driver getting the pallets from the rack and placing them onto the stage, and then from there, putting the pallets from the stage into the containers. And then there's the unloading process, which consists of moving the pallets from the containers onto the staging area, and then from there, placing the pallets from the staging area into the racks. So here's just, I guess, a breakdown of the times that we decided to take when we went to visit the warehouse. And the green consists of the times that they were working, where the red is the delays that occurred within the processes. So here's, I guess, more of a breakdown of the unloading process. As you can see, there's a 9% total delay that occurs, which is a lot considering the total time that it takes to actually unload all of the containers. Okay, here's the loading process, and here's another breakdown of the different operations within it. As you can see that the checking list consists of 29%, which is an area we decided to focus on in order to decrease the time it takes for the checker to check the lists off the item. And then also the rack to stage, we decided to improve using the different layout recommendations. So one of the biggest sources of waste we saw was the forklift gridlock delay, which occurred when there were a bunch of forklifts that would get stuck within the aisles of the warehouse. So we decided to fix that with a different layout design. And as you can see, it took up 8% of the stage to rack operation. So Mariella now is going to talk to you about that.
So as Sebastian mentioned earlier, one of our goals for this project was to standardize workflows in order to make the warehouse more efficient. So one of the things that we decided to do was to compare the loading process from the Puerto Rico warehouse to the Miami warehouse to see which one was more efficient and to be able to implement that if theirs is more efficient than ours. So the way that these processes are different is that in Miami, there's one single operator that is responsible for the entire loading process. So the forklift operator retrieves the pallets from the racks and then stages them, scans them, and is able to load them onto the container. Whereas in Puerto Rico, they work in teams of 2. So the forklift operator takes the pallet from the racks to the stage, and meanwhile there's a checker, and his job is to scan the pallets while they're being retrieved by the operator, and at the same time he's kind of strategizing how to place them into the container. And then the forklift driver again gets them from the stage into the container. So as you can see in Miami, we have that it takes 4 seconds to scan each of the pallets, and there was a 7-second waste, which that was allotted to the time that they kind of used to plan how they're going to fit things into the container. But for us, it was 11 seconds, and the remaining time was them waiting for the operator to go back and forth from the racks to the stage. So it was kind of just idle. So here we have a comparison analysis, and you can see our process times for each of the 3 processes, which was staging, scanning, and loading. And you can see that for the total time in Miami, it was 4.18 minutes, and for Puerto Rico, it was 9.84 because we had 2 people using up this time. So Jeff's going to go into a little more detail about the savings that we acquired by adopting the Miami process later on, but here's our second goal that we decided to focus on, which was a pallet storage system, which we mentioned earlier. And currently in Puerto Rico, when they store pallets that arrive to the warehouse, they just kind of get them from the container and look for an empty spot on the racks and put them on there without really knowing, like, they don't have any assigned location. So they kind of place them there, and then you kind of have to retrieve from memory later on. When they have to load a container, they have to remember where they placed them. It is a small warehouse, but they still get a lot of confusion. So when we were doing our time studies, we noticed a search delay that we documented, which was the time that they spent looking for pallets. Sometimes they would go through every single aisle in order to find it because they couldn't remember where they placed it. So this is our storage system that we came up with. So the operator would bring a pallet to a location, and the location is basically, they would be assigned a 5-digit barcode. And this is the barcode over here. So the first digit determines the aisle location. So here A, B, or C. And then the second one would be the column width. So you have under the A, B, or C, 1 or 2. The third spot is the number of the bay, so 1 through 9 over here. And then the fourth digit is the level on the rack, and all the racks are 4 levels high. And the last digit is just the spot in the bay, so 1 or 2 right here. So this way they would be able to scan an item once they place it in a location, and then later on scan it again to be able to retrieve it, and it would tell them exactly where they put it. Here we have our search delay that we found from our time studies, and you can see that it's 2.9 minutes per pallet, and we determined that with the storage system we would be able to get rid of this delay, and that would save us about $8,681 per year. And now Jake's going to go into more our alternate layouts.
So the next deliverable for our project was a layout analysis. They gave us an original base layout, but we came up with 3 more, keeping in mind maximizing the open space and minimizing travel distance. So here's the base layout that currently exists in the Crowley warehouse. If you can see up here, they have 2 types of racks. They have the active racks, which are the 3-story racks that are in yellow, and the 4-story racks, which are in blue. The second type of rack is a storage rack. These racks are untouchable. There's 99 of them currently. Companies purchase these racks, so they expect this storage space to be there. We also have the rack centroids in red here, and we have the stage centroids in green, which are down here. And these, combined with the doors down here, are used to calculate our distances. A couple of issues that we found in this layout is that the staging space is very small. The rack widths are very aisle to aisle, and there are so many active racks that are just sitting there unused right now. So here's the calculation matrix for the layout, and from those centroids and doors, we were able to calculate these distances. And from our original time study for each process, we were able to calculate the total times. And combining those 2 things, we can look here at the cost analysis. We were able to come up with the total cost to process the pallet, the total processing cost per year, and the total cost savings per year. Obviously, there's no cost savings here because this is what currently exists. Here is, from our historical data, we were able to come up with that this peak right here is 670 pallets. And what that means is that on any given day, there will be at most 670 pallets within the warehouse. And what that allows us to do is all of those active racks that I spoke about before that are sitting unused, we're able to take away about 30% of them. So this will give us the optimal amount of racks for in our future layouts that we suggest. So here's our first suggested layout, which is a modified base layout. As you can see, it's very similar to the original. Taking out 30% of those racks, we were able to create much more staging space here. We pushed all of the storage racks to the back because they were just clunky and in the middle and creating a lot of forklift delay. And we eliminated all of the 3-story active racks. Again, you can see the centroids here used to calculate distances. And here's the modified base layout calculation matrix. Again, with those centroids, we were able to create these distances. And then from the original base layout, we were able to come up with a ratio from the distance to time. And from that ratio, we applied it to these distances, come up with these new times in red. So it's sort of a projection of how long each of these processes will take in this new layout. And with that, we come up with this number here, which leads us that this layout, our first suggested layout, will save us about $18,000 per year. Now our next layout is this V-shaped layout, and what we wanted to do here was explore a big, larger staging space. Again, we pushed all of the storage racks to the back and all of the active racks to the front. And with this layout, using the same philosophy, we were able to come up with $7,000 in savings per year. And in our final layout, this is the U-shaped layout. We wanted to take into consideration, again, the large staging space and some flow considerations with these little breaks right here. Again, the storage racks are in the back and the active racks are in the front. From here, with the same philosophy again, we were able to calculate that this layout will save us about $17,000 per year. And here's a snapshot of our simulation. From the point of the simulation is to track a pallet from the start to the end of the unloading and loading processes. And from our time study, we were able to come up with distributions using the input analyzer for every single process. And with those ratios I talked about before with the distance and the time for all the new layouts, we were able to scale back the distributions to modify perfectly for each layout. And we ran the simulation and then compared our results, which just confirmed the results. And now Jeff will take you to the conclusion.
Cool. So we're going to kind of recapitulate a lot of the points of our analysis and then also quantify the gross savings and then also lay out some future recommendations and places to go. So we're going to go over the process we're adopting from the Puerto Rico warehouse, some analysis we did on the minimum number of staff they need to actually complete to fulfill demand and how they can better match their staffing allocations to demand, save money there. Also, for our storage system, quantifying the savings from that as well as the savings from our warehouse layout recommendations. So from adopting Puerto Rico's process, now that we're going to have one person performing all these activities, we're going to introduce about 8 seconds of added waste, which is in lieu of the checker helping them support and plan how they're packing everything into the container, as well as respond to some other out-of-control activities. So that's represented in about an added 8 seconds per pallet. But in total, this takes what you had to throw 10 minutes of labor at into 5 minutes, and amounts to $33,000 in gross savings per year. Now, this is just from time we shaved off of value-added activities, but what we're actually doing is not just reducing activities, we're eliminating an entire role. So Parkinson's law is something relevant. It says that the amount of time it takes to complete a task grows to scale to meet the amount of time appropriatized for that task. So we think that by, the data shows that we can actually take all these activities, put it into one role, and we think that by actually adding a little bit of pressure to this role, we'll be able to get more with less, and it will increase over $33,000. So we did an analysis on the minimum number of staff they need to have to fill their demand, and it comes in dramatically lower than what they are actually staffing, about 3 times as much. So management definitely has room to decrease the amount of staff they had, but another analysis we ran, this is over a 2-year period, the month-to-month demand, and it's standardized so you can see relative how the months stack up. There's huge swings in demand and trimesterally about 3 peaks. So we advise management to start pushing down, easing down how much they allocate for staff, but understanding that it's going to widely fluctuate. So with this information, they can better create a variable staffing model to match the anticipated demand in a single month. So the system of storage and retrieval to make it so they don't have to search up and down the racks is going to eliminate the time they spend searching, which is immediately $9,000 per year. And with all those forklifts wandering the racks, trying to find their pallet, it's as much as 10 minutes sometimes. We're going to eliminate a lot of traffic in the warehouse. So some of this waste and some of this waste will also be reduced, creating about a total of $13,000 in that time savings. So this is the original warehouse layout going to what we've now improved. The most important thing is all this storage space that was creating a huge block right here that they just had to navigate around. They would even use these aisles to just stuff pallets in for staging because they were out of room. We're moving that to the back and opening up all this room up here so they're not going to have to move pallets in the way of things they need to get to, or have to move pallets out of the way and reduce a lot of the congestion. So overall, this warehouse revamp takes about only $2,000 to implement. And it's going to create a 10% increase to the staging area here, a 10% reduction in the time it takes to process a pallet, as well as a 20% decrease in the total staffing you need to allocate. The total amount of racks they have to have invested is reduced by 15%, and we standardized all the aisle widths so that they don't have to switch forklifts as they were having to do to get in some more narrow or more wide aisles. So it adds a lot more flexibility to the layout. Overall, across all of our recommendations, we're saving $64,000 per year. And then, like I said, the change is a very small fraction of that, so it's a lot of savings we're really proud of. So this increases their bottom line. Their profit percentage goes up by 5%, but it still leaves them deeply in the red. So we want to really think about what kind of process changes need to be laid out further to make this efficient. When we first got to Puerto Rico to do our time studies, we noticed it was just a huge beehive of activity. All the workers take pride in being the most efficient NVO warehouse across all of Crowley, and they have a very individualistic attitude of solving their own problems, finding their own best way to get the job done in front of them. But you have to wonder if this entrepreneurial attitude gets in the way of creating good outcomes and good standards across the organization. And if this sense of local optimization actually gets in the way of creating a consistent optimization for the whole, which is direly needed. Taishi Ono, the founder and father of Lean and the Toyota Production System, said, without standardization, there can be no improvement. And we saw a lot of really atrocious examples of lapses in standardization. As I said, pallets being just shoved places, having to be moved out of the way. And it seems to be very efficient because they're moving so fast, but in reality, they can do a lot more with a lot less movements. So how do we fix process? And where are we going forward? We spoke to some of the warehouse workers there, and they had actually worked in competitors in the same business. Their NVO warehouses don't have any racks at all. It's a completely open staging space. And this enables them to just move things out of the pallet to the stage and not have to move it again to the storage. And that eliminates half the touches. So we want to recommend to management to do further analysis if they can modify their business plan to completely eliminate their racks, to reclaim that idle storage space and terminate those contracts, reclaim all that empty space, go to an open floor, and then invest more heavily in their IT systems to improve the coordination so that they have set places on the stage, that they always know where a pallet goes. They can communicate with the containers on where to dock to be closer to their freight, and overall just improve the coordination between different processes. Another quote is by the founder of Quality Management, saying, a bad system will beat a good worker every time. So while the workers in Puerto Rico have amazing diligence and are very capable, we want to kind of think beyond the scope of this project to think of kind of further alignment we can create in the business model all the way down to the process. So we want to recommend to the business that they invest more in analysis. If they can eliminate their racks, if we can go to an open floor layout, and invest more in their IT systems, which are pitifully underinvested in right now, and that they can kind of be more like a modern delivery system and be able to push that negative 70% profit margin into the green. So that was the scope of our project, and we can take any. Jake wasn't there, but so we had to Photoshop him. Does anyone have any questions? No questions?